Okay, now, if there's any one big on thing with these we're doing, we've got two parts. You've got equations and we've got inequalities. The big thing is, no matter which one that we're doing here, most of the time, not every single time when we're going through these, but most of the time, you're going to have two answers. So I kind of put a big asterisk beside that because that's something you need just to make sure you've got here. So you're going to need two answers most of the time. And I'll try to remind you of this one. This is usually one of those things I'll try to remind you of it when we get right before the test, because it's one of those things that it's easy to kind of slip up on it. So I'll try to refresh your memory just to make sure everybody's good when we get there. All right, and when we're doing the equations and we're doing the inequalities, for absolute value equations, first thing you're going to do is you have to get the absolute value or we'll say the absolute value symbols that you get, because again, that's where you've got the two lines going around whatever part it is you're looking at. You've got to get the absolute value symbols by itself on one side of the equation. Doesn't matter if you get on the left side or the right side. You just got to get it by itself on one side of the equation. Now, and if that doesn't, sometimes people get off on that one. Here's the big thing you got to do: is you cannot have anything on the outside of the absolute value. Because depending on the equations that we work with on these, you may have some things on the inside, and that part, there's nothing. That's when we'll kind of do the step 2 to kind of get rid of that part. But when we're getting absolute value symbols by itself on one side of the equations, that just means everything on the outside of that absolute value, you've got to get rid of it. You may have to add it, you may have to subtract it. You know, there might be a little bit of division in there, but it's the key thing is that everything outside of that absolute value symbol is gone, so that all we've got is just the absolute value symbols and whatever's on the inside of it. Okay, so that's the first step, which really shouldn't be too bad. You're just going to add and subtract and maybe a little bit of division, depending on the problem. So overall, that one really shouldn't be too bad. Here's where you have to kind of stop and check yourself, because there's a step 2, and there's like a 2A and a 2B. If you have the absolute value of x, you know, and again, you may have some stuff on the inside or out on the outside, but if you get the absolute value all by itself, and that's, I'm running out of ring, so I'm going to put that down here. If that equals a negative number, then here's where you get to stop and don't do anything else. Because if you get that absolute value equals a negative number, your answer is no solution. Or if you want to say that that's never true, to kind of stick with what we did in the first couple of things, we'll take that one. Because if you kind of go back to what absolute value is, absolute value is a measure of distance. And if you're measuring distances, you don't talk about negative distances. You know, if we're going east, we say we're going 20 miles east, or whatever we're going to do. If you turn around and go in the opposite direction, you don't say I'm going negative 20 miles to the east. You know, you're going 20 miles to the west. So whenever you're doing these, once you've got your absolute value, if that's a negative number, you don't do anything else. You just tell me your answer is no solution, and there's no other solving you do with it. And some people kind of like that because they're like, hey, I don't really have to do anything. Well, okay, yeah, and that's one of those cases where it does. So, you know, if you get a negative number, you're good. That's all you have to do. Now, the 2B part. So, if you do this and you have a positive number. You're going to split the equation into two parts. With one negative number and one positive number. Alright, I'm going to show you like the shortest absolute value equation in the world, because there's really not much to it other than a number like this. So we're going to assume we've done 2 or 3 or 4 steps or whatever you've got to do. And let's say you've got it to the point where you've got the absolute value of x equals 10. You know, we've moved some stuff around, we've divided by the stuff on the outside, we've moved all this, and you get to the very end of it, and this is that last step that you got where you got the absolute value by itself. If you get it here, then basically you can tell me that x would be negative 10, or that x could be positive 10. And that's where you get your two solutions. Because remember, absolute value means if you plug a negative number inside that absolute value, if you do the absolute value of negative 10, that answer is going to be 10. If you did the absolute value of 10, that's still also going to be 10. So if you plug a negative number on the inside of parentheses, it winds up just making that number out to be a positive number. So again, this is basically, we're doing these on a number line. So if they tell you that your distance is 10, you can go 10 spaces to the right, or you can go 10 spaces to the left. And that's really what distance, when we're talking about absolute value, that's what we're doing. We're looking at the distance on the number line. So you can go 10 spaces to the right of it, or you can go 10 spaces to the left of whatever number you're talking about. You get the two numbers that you're looking at. Okay, now there is one other, and then here's one other where you get kind of a trick question. Because we talked about a negative number that you get no solution. You could talk about a positive number. What's the only other type of number that's not positive or negative? What's in between positive and negative numbers? 0, right? 0 is kind of a neutral spot. So if you happen to get that you get absolute value of x equal to 0, and you could call this like a 2c if you want to. And this one's really not a big deal. If you have absolute value of x equals 0, if you split it up, is there such a thing as negative 0? There's not really. I mean, because 0 is 0, it doesn't really have a sign with it, so that doesn't really make sense. So if you have absolute value of x equals 0, you only get one solution. Because negative 0 and positive 0, well, they're still really the same thing because it's 0. It's neutral. It doesn't have a value. So if you do happen to get absolute value of x equals 0, you only get one solution. Doesn't happen a lot, but it does happen every now and again. Okay, let me do this. Let me show you like 2 or 3 questions where we're going to go through and solve these and show you how this sets up. And then there's one other little special case we got to show you. And then we'll show you the inequality stuff that goes along with it there. So let's go with absolute value of 2x plus 4, and let's let that equal 18. Okay, now this one, again, here's what this one's a little bit shorter because you've already got the absolute value over here by itself. There's nothing on the outside of it, it's all by itself. We've got the 18. And once you've got this absolute value all by itself, again, one time this number on the inside could be a negative 18. So we're going to let 2x plus 4 equal negative 18. Or that number on the inside could be a positive 18. Okay. And then once you split up, the solving equation part really shouldn't be too bad. You've got 2x plus 4, so let's go minus 4. Then divide by the 2, so you got x equals negative 11. Alright, and then on the other one, now the steps are going to be the same thing. This one's still 2x plus 4, you're still going to subtract 4. And then when you divide by 2, again, same steps again, this time you're going to get x equals 7. Okay, and there's your two answers. So as long as it's just a normal, as long as it's not a trick question, you're going to get two answers when you get finished with this thing. All right, let's give you one that's a little bit longer. You got to do a little bit more work here. So let's go with 2 times the absolute value of x plus 9 minus 7 equals negative 3. Alright, now, here's where sometimes people get a little bit too excited. I want to show you this one first, because sometimes people see this and they'll go, oh, that's a negative number. I don't have to do anything. It's no solution. Alright, yeah, this is a negative number, but you got all this other stuff that's around the absolute value. You got this 2 and this negative 7 that you've got to get rid of. So before you get too excited on this one, again, you got to get the absolute value by itself first and then check it. So before you do anything at all, you've got to get rid of this 7. And then you've got to get rid of the 2. To get you there. Okay. And again, just going back and thinking about the things that people have done in the past to kind of get them thrown off on these. So even though it may be a negative number in the beginning, don't get too excited. Don't jump too quick. Make sure you get the absolute value by itself first, then see whether you've got a positive or negative number. Once you get here, it's positive. Now you actually can split the thing off. So you can have x plus 9 equal to 2, or x plus 9 equal to negative 2. So make sure you get that step 1 first before you get to the second part. So you always got to get the absolute value by itself first. Oh, my bad. Yeah, that is positive 2. My bad. Alright, and this one, a lot quicker solving on this one, just subtract 9 from both sides. So this one is negative 11. This one will subtract 9 and make it negative 7. Okay, I'm going to give you one more of those. And then there is one little trick question thing they might throw at you on some of these. And I'll show you that first. And then we've got to look at the inequality part. Alright, so let's go with 4 times absolute value of 2x plus 5 plus 15 equals 6. Alright, so same thing with this one. You've got the absolute value that's here in the middle, so you've got to get rid of the 4 and the 15. So first thing is we'll get rid of the 15. And then once we've got rid of the 15, we'll go back and divide it by 4. Alright, now, 2 things happen here. Sometimes people get this when they go, oh, it's a fraction. I got to start messing with a fraction. Alright, it is a fraction, but more importantly, what kind of fraction is it? Or what sign does it have? It's improper. It's also a negative fraction, right? So if absolute value equals a negative number, what do we do? There you go. Just no solution. So it doesn't matter that it's a fraction of any kind. The key thing is it's negative. And once this absolute value is all by itself, and that's a negative, proper fraction, improper fraction, it doesn't matter. It's negative, so then you just stop and say, all right, it's just no solution there. So when it's no solution, I mean, that's it. That's all you do. Get the absolute value by itself. If that's any kind of a negative number over there, that's all you got to do. Then you're good to go. Okay. Now, got one other little thing, and this is almost like another trick question part of the absolute value here. The good thing with this one, though, is it's labeled different than all the other questions that we'll do. And they're going to say it's an extraneous solution equation. And basically, here's what that means, is that you may have a solution or solutions that don't work. When we're saying don't work, that means that they don't check with the original. Here's what it comes down to. You have to go back and check it. You have to go back and take whatever part you're doing. You've got to check it in the original and see if it actually makes that original equation true when you're going through this thing. Now, the good news on these equations are they're going to tell you to check for extraneous solutions. So they go ahead and give you a heads up right off the bat and tell you, all right, you're going to have to go back and check this thing in the original. Because it may be an answer that, yeah, you may get an answer off of it, but it may not be actually an answer that makes sense and works when you go back to this thing. Alright, so you're still going to do the same thing. You're going to split it off where you got the absolute value, take that away, make one part of it negative, and then make the other part of it positive. Okay, now with the negative, if you get one like this, and the biggest thing that makes this the extraneous solution is it's not just absolute value equal to a number. Really, when they put that x in there, that's when you get those extraneous solutions, because that kind of messes things up when you put that extra variable in there. So when you change this sign, instead of just changing it, you would change it, if that was just a 14, you'd make this a negative 14. But you also have to change that 7x to make them both negative. Alright, so you've got 5x and the negative 7x, and again, I kind of like getting rid of the negative variables, so if you've got a negative 7x, let's make it so we can add 7x to both sides. If we can keep the numbers positive, that usually winds up being the better option for things we do. So we've got 12x plus 2 equals negative 14. Get rid of that plus 2. And then divide by 12. Alright, now here's one fraction answer that you get that you can simplify. You've got negative 16 over 12. You can divide both of these numbers by 4 to make that negative 4/3. So there's one answer. Okay, and then we're going to solve the right-hand side over here to get the second answer that we need for this one. Alright, now this one, again, you could do the get rid of the 7x, but you've got 5x and 7x. If you do these, get rid of the smaller amount of positive, because now you're just going to subtract away 5x. And that way this x winds up being positive, which usually makes things just a little bit easier. Get rid of the 14. And then we'll go back and divide by 2. So for that one, x winds up being negative 6. Okay, now, and here's where you have to go that extra step. Everything else up until, if it didn't say check for extraneous solutions, that would be your two answers. You would be done. That would be it. But for this one, they tell you have to check for extraneous solutions. So you're going to have to take those two numbers and go back to the original equation, and you've got to check it. So we're going to take those two answers and take them one at a time and check it. So we're going, first thing we'll do is we'll plug in the whole number, because it's, most people would rather wait and do the fraction because that's the toughest one. So let's plug in the negative 6 and see what we get here. Alright, plug in the x for negative 6 there, plug in the negative 6 there, and the rest of it we're just going to work it out. Alright, and if you haven't worked in absolute values for a little bit, we'll just work on the left-hand side for a second. We'll come back to this right-hand side. So just kind of forget about that one for now. When you're working on this side, the absolute values are basically like parentheses. So you just work inside that parentheses. You've got 5 times negative 6 plus 2. We'll go ahead and do 5 times negative 6 for negative 30. And then negative 30 plus 2 will be negative 28. Alright, now, and if you take the absolute value of any number, it makes that number positive. So if we take the absolute value of negative 28, that's really just a 28. Alright, so you got this side all the way down to a number. Now we're going to do the same thing on the right-hand side, and we're going to look at these two numbers. If they're both 28s, we're good. If one's 28 and the other one's something else, then it's not good. 7 times negative 6 is a negative 42 plus 14. Negative 42 plus 14 will be a negative 28. So does, and that's the question at the end, does positive 28 equal a negative 28? Well, almost. They're both 28s, but one's positive and one's negative, so nope. So that means x equals negative 6 doesn't work. So what we can do back up here, let's go back up real quick. Where we had this x equals negative 6, that answer's gone. So that one's out. So then we'd have to go back and check the negative 4/3. Now, and just so we can save a few minutes here, just want to make sure we got plenty of time with a little bit of breathing room at the end. If we do go back and check negative 4/3 does work. So if we go back and check it, negative 4/3 does check. So x equals negative 4/3 is the only solution. So even though we started off with two answers, two possible answers, the negative 6 didn't work, so we chunked it, it's out. The only answer that does work is the negative 4/3. And again, just to save us a little bit of time, because I want to make sure we get finished up and not lose any time on anything. The negative 4/3 does check when we go back and plug it back in. So that, and we started with 2, but we only had 1 because that's the only one real solution that works there. Okay. Now, and we'll put one other quick sentence here, and then we'll get to the inequalities, get to less than and greater than. Because this may possibly happen if neither answer checks. You know, somebody gives you two solutions. You know, you want to drive 15 or do you want to drive 10? You're like, I don't like either one of those. If you check it and neither answer checks, then you have no solution. So that is a possibility that if sometimes when doing these problems, when they say to check for extraneous solutions, it may be that neither answer works when you go back and check. So if y'all get this first little thing here in the beginning, that should kind of, and we'll do one problem each just to show you what happens. So we got absolute value inequalities. All right, and there's two types. And what we're going to do is we're just going to take underneath there, I'm going to get a little bit bigger piece of paper. Just split this thing, just draw a line right down the middle. And we're going to do one type on one side of the line, we'll do one type on the other, and just show you all the different things that kind of go with this thing. And it's more of it's just kind of just recognizing what it's going to be. All right, here's the big thing of the day. Here's the one thing you've got to catch. If you get absolute value of x so that it's less than some number, because you really only have two choices. It's either less than or it's greater than. Now, and whether you put the bar underneath it or not, that doesn't really matter. It's more of it if you have less than, you know, or you can have less than equal to, you know, same thing with the greater than. It could be that you've got greater than or equal to. But the key thing is you've got greater than or you've got a less than symbol. If it's either one of those, if it's either one of these two where you've got less than or less than equal to some number, the key thing you're looking for, it always keys on the symbol. If that is less than, always, and here's how I kind of used to get to think about it, because when I had to learn these, when I was in y'all's shoes, honestly, sometimes I kind of guessed on these problems because I remembered sort of, but I didn't remember. And I didn't really come up with a way to make it stick in my head until I had to teach this thing. That I had to start thinking about that less than, really I had to start thinking about it as being less than, which means this one is going to be an and statement. And whenever you have an and statement, you're going to sandwich this absolute value thing between a positive and a negative number. Okay, and then on the other case, So yesterday we did and statements and or statements. So for this one, if that's greater, and this is the one I really memorized when I had to start doing this. It was greater. Say it like you're, in the Beethoven. Not Beethoven. Shakespeare. There we go. That's what I'm thinking about. Put the accent on it pretty well. Greater. So if it's greater, or if it's greater, it's an or statement. And when you do an or statement, it looks like, when you get finished with the graph, it looks like oars on a boat. This one, again, it's a sandwich one because you're going to have 2 points and you're going to sandwich and basically shade in everything in the middle of this thing. So if you have absolute value of x less than, it's an and statement, which means you're going to sandwich it between 2 numbers. If it's greater, it's an or statement, and it should look like oars on a boat. If you put the oars on the boat, they're what's in the water, right? And then you've got this gap in the middle when you're in the boat, so that's kind of what it looks like. This one, you're going to have a gap in the middle, and then you're going to shade everything on the outside edge. All right, so I'll show you a couple examples. We'll do 2 examples, and that should pretty much wrap us up. So we got to go through. We'll put this one over here because it is less than, so we'll put it over here. So we're going to do something like this. We got absolute value of 3x minus 4 is less than 8. Okay, now when you sandwich it in, you're going to sandwich it, you've got the 8 that's here. You're also going to turn around and sandwich this thing between negative 8. So that 3x minus 4 is going to be between positive 8 and negative 8. So whatever this number is that they give to you here, you sandwich it between the positive and negative. Just like we did before when we were doing absolute values. We had the positive side of it, you had the negative side. The only thing that's a little different on this one is that this symbol stays the same. They both kind of sandwich in this way. Okay, now here's where we're going to do this one just a little bit different, because yesterday we actually had the and statement in the words when we went through this one. This one, it's there, it's just kind of assuming that it was here. So here's kind of the way you look at this thing. If you had to solve that equation, or that part of the inequality, what's the first thing you would do for this little part right here? Alright, you'd add the 4, right? Okay, what would you do if you had that part of the inequality? Same thing, right? You'd still add 4. So on this one, you added 4 here and here, if that was your inequality. If you had this inequality, you would add 4 and you would add 4 here. So instead of doing it like in 2 separate parts, just do everything, all 3 parts at the same time. So now you've got negative 4 is less than 3x. Is less than 12. So for the sandwich, when you sandwich these together with the less than, just put it all together and do everything all at one time. Instead of doing it 2 separate times and having, basically you just, instead of doubling the work, you get to do it just twice as fast for this part. And if you haven't done those that way, it takes a little bit of practice, but once you do a couple of them, then it starts to kind of roll pretty easy. Alright, if that was your inequality, you divide by 3. If that was your inequality, you would still divide by 3, so we're just going to take every single thing and divide them all by 3 at the same time. So it's going to leave a negative 4/3 is less than x, which is less than 4. Okay, now, most of the time when you're doing these graphs, you usually, especially for the test, you're probably not going to get a fraction or a decimal like that one. But for one like this, now if you do, let's see, if that's 4, 3, 2, 1, 0, negative 1. Negative 4/3, if you check your calculator, that'd be like negative 1.3. So that circle would go somewhere between negative 1 and negative 2. It'd go right about here. And you shouldn't have many of those, hardly if any of those. You may get one where you're going to be kind of on the decimal number. This one we're back at positive 4 here. So once you get your two numbers, as long as it was an and statement we started with, you just sandwich or you shade everything in between those 2 points. I tell you that, that's, if you had a sandwich, that's kind of the meat in the middle, and then there's your bun on the top, bun on the bottom. There's your sandwich. Or if you're vegetarian, that's just a bunch of lettuce and ketchup and whatever else you put there. Ooh, it could be a tofu burger. Never had a tofu burger. All right, so there's one where we're doing less than. We'll do one more where we're doing the greater statement, and then that'll wrap us up. All right, and again, the one key thing that we're trying to hammer home on this one, when you're doing the absolute values, it all depends on what the symbol is as to which way it's going to go. And if you don't want to memorize both of them, just memorize one, and if you memorize one, then the other one has to be the other thing. I kind of like this one because this one is greater, and it's greater. It's almost like Thor. You could start talking like Thor if you wanted to there. So when you got the greater, just think about it as greater when you're going through the thing. So it actually makes it out to be an or statement. So when you do the or statement on this one, it's 5x plus 10. Do the 15, we've got it here. If you change this one to a negative 15, only thing is because we changed this sign from positive to negative, you also got to change this sign from being a greater sign to being a less than sign. So that's the only little trick with that one is you do have to flip that sign for that part. All right, once you've done that, though, now it's just two separate inequalities. For this one, you'll subtract 10. 5x is less than negative 25. When you divide by 5, you get x is less than negative 5. This one, we'll do the same thing. We'll start off by subtracting 10. And then you're also going to divide by 5. Okay, and again with the or, it's like oars on the boat. You put one oar over here, it's got to go into the water, so it's going off this way. When you do the x greater than 1, you put this one here, and then the oar's going off that way. And there's your gap in the middle. Always try to think about it. This was kind of like your boat in the middle. And y'all can laugh because this is going to be terrible. I'm not an artist at all. There you are in the boat, and you're going to have arms coming over here, and then you're grabbing hold of the oars, and then you're rowing, right? That's kind of the way I always thought about it. Because if you get oars on a boat, that's what's in the water. The oars go in the water, and then, in the middle, you stay nice and dry. Now, of course, don't do that on the test. And if you want to, just for fun, you can. But, just leave it blank and open in the middle.